Hi guys, welcome to week 2 of games programming. This week we're going to be looking at hardware and software. So this week's decisions that you really have to think about are what hardware are you going to implement for and which software are you going to use. Obviously these questions are really linked. For some hardware systems it will say, okay, if you want to use this hardware you're going to have to use this software, and likewise. So let's think about this in some more detail. The hardware options that are available to you are PC. You can design for a desktop for PC, or you could design something like a VR game that runs from the PC but is shown on a VR headset. You could design for Mac if you wish. Design for iPad, iPhone, any other iOS device. Design for Android tablets, Android phones. You might decide to actually design for Kindle, which runs on Android, but it's a separate way of selling it when it gets to that stage. Another phone, Windows phones are kind of dead and buried now because they're no longer being made, but there might be another kind of phone that you want to develop for. Console, it is possible to develop for consoles. Some of them are really hard to get released on, others are slightly easier. It's something you can at least think about. You might want to develop for virtual reality, augmented reality. There's various options for doing that. So for virtual reality, you can go for something really quite complex, like writing for the HTC Vive that we have upstairs. Or you could do Google Cardboard. We've got quite a lot of Google Cardboard viewers, and then you'd actually probably be designing for Android. We've also got Internet, which obviously is not a hardware option. It would hopefully run any place, but I put it with the hardware options as in you're kind of thinking about it in the same sort of lines. You're thinking about where is this going to run, who's going to play this game. There may also be others. I am not sold on the list above. If you come to me and say, can I develop for something else, I am probably going to say yes. So when you're thinking about what kind of hardware, you've really got to think about what is your game. In particular, if it's a really casual game that somebody's going to pick up on the bus and play for 10 minutes on their daily commute, it's going to be on a mobile device. Most people don't carry around with them a PC that they get out in the bus and they sit on their knee and they try and play a casual game on. Okay, so you're thinking mobile phones, small tablets for a casual game. I suppose you're also now thinking Switch. I see quite a lot of people playing Switches on the bus, but it's hard to develop for Switch, so we probably won't go there. However, if you're going to make a 3D first-person shooter, a really, really powerful game with a full 3D world, you're probably going to require quite a lot of processing power. So in that case, you're probably looking at running it on a PC. The second thing to really think about is who is your audience? Firstly, and most importantly, what hardware will they have access to? If you're developing a game for real hardcore gamers, they are likely to have a gaming PC, and so you can develop with that in mind. If you were developing a game for, say, kids, often they have tablets, and that's what they've got access to, so you want to think about tablets, so forth. Older adults are actually kind of the same. They tend to have tablets, sometimes they have mobile phones. So you want to think about that. You also want to think about what hardware will they be familiar with. So as a story here, I have a niece who's 6-year-old, and at Christmas I teach her how to use a mouse. She's been using IT and technology since she was a baby, but she doesn't know how to use a mouse because everything she's ever used was touchscreen. So you might not want to think about a mouse and that sort of idea of using a mainstream computer for young kids. Okay. Whereas, again, hardcore gamer audience will probably have gaming mice, so they'll really be used to that, and that's what they'll be expected. So, I've mentioned this already, but I think the next thing to really think about is what controller. So some controllers that people do use. Keyboard. A word of warning, if you're thinking about using keyboard, try and limit the number of keys you're using because people just can't remember the full mapping of all the keys. If, for example, it was something like a typing game, then obviously you would want to use all the keys. In that case, you'd want the user interface in the game to actually make it clear which key they were pressing when. Okay. Or you can think about mouse. That can be a traditional mouse, or it can be a gaming mouse with a far faster click speed, depending on the type of game you're doing. Games controllers, games pads. We have some USB games pads in the department which you can borrow and you can think of using. They're actually quite good for some audiences because people are used to them. People are used to having an A button that jumps, for example. Touchscreen. If you're doing sort of an iPad or an Android game, it's likely to be touchscreen. That's your main interface. It could also be the accelerometer in those cases. Quite often, if it's like, sort of like a maze ball tipping game, you end up getting the accelerometer to be your main game controller there. It could be Kinect. We have some Kinect development kits. So if anybody's interested in Kinect, then talk to me. We have a development kit for that. For those of you that don't know, Microsoft Kinect is a camera system. So the way you control the game is by physical movement, physically moving your hand, so forth. I'll be honest, that is not an easy option, but it's there if you want it. Or it could be virtual reality. Virtual reality, as I said earlier, can be anything from really hardcore virtual reality, from the HTC Vive to the Oculus Rift, both of which we have one of in the school, so you can use that if you wish. Or a lot easier virtual reality is things like Google Cardboard. We have actually some really nice Google Cardboard viewers, like plastic viewers, where you put a mobile phone in. So you might want to think about that as well. If you plan to make this into a full product and make money from it, and I really hope some of you will, I think it's great to also think about the fact that you own this project, you own this game, the universe has no rights to it at all. So if you want to make some money from it and you want that to be part of this, that's absolutely fine. If you want to do that, you've got to think about route to market. You need to consider how you are actually going to sell it and what your sales route is. Some common sales routes. Actually, the most common is probably iTunes, and the only students I know who have made money from their games went down the iTunes route and made iOS games. So, because it's actually really easy to get something onto the iTunes store. If you're doing Android, the Google Play Store is also there. There's also the Kindle Store on Amazon, which is a slightly limited version of the Android store. Might be useful if you're making a game for really young kids, because you might know that it's a Kindle Fire for young kids. So it's a way to directly market to that age group. There's Idea Xbox, if you want to do an Xbox game. That also allows you to put things on the mainstream Windows PC. There's currently Steam Greenlight, which is a big community project whereby you put an idea for a game up and people ranked it, so forth, and if Steam liked it, eventually they commissioned you to make the game. In spring of this year, that'll be moving to what's called Steam Direct, which will be a far easier way, I think, to get your game on. You won't have to go through this greenlighting service. You can do the internet itself with something like Google Ads in order to get money from Google Ads. And there's also the Chrome store, which allows you to sell web-based things that integrate with Chrome. Then you've got to think about not just route to market, but how will you actually monetize? Will it be an upfront purchase? Will it be the game costs $1.99 and for that you get everything? Or will it be what's called in-app purchases? In-app purchases tend to fall into two categories. There's kind of the game coins, where you actually buy stuff that you can pay with in the game. Loot crates being the very famous and somehow ethical dubious version of that currently. We'll come back to that when we get to ethics. Or you could have in-app purchase for new content. So you can say, give 10 levels for free, and then have in-app purchases for the rest, or in-app purchases per 10 levels, or something along those lines. In order to think about how you're going to market this, you've really got to consider the size of the market. So there's some really interesting graphs, which I encourage you to go and look at gs.statcounter.com, which really go through how big the market is in different countries and different nationalities. What they actually look at is browser usage from different devices. But it gives a really good indication of the amount of uses of different devices internationally. What is the popular phone in Africa? What is the popular console in Australia? You can find out by looking at this data. You've also got to think about your market strategy, how many people actually pay for apps. And I found this graph really interesting because it shows you how much people actually pay for apps. So on the average iPhone, there are 7 free apps for 1.8 paid apps per month. That's what they download per month. On the average iPod Touch, you can see that this graph's a bit out of date, but it's the most up-to-date one I could find. You could see there's 1.6, and yet there was a bit less than Android and a lot less WebOS. So it's interesting that your average Apple user seems to pay more and buy more stuff than the Android to the WebOS, which is worth considering. We've talked a little bit there about the hardware. The hardware often has, as I'm sure you know, a real direct effect on the software. So if you choose some hardware systems, that will say, okay, I'm going to have to develop in this language in this way. But let's look at the different software options that are available to you. So if you want to do iPad and iPhone hardware, there's various ways that you can actually write something for iPad and iPhone that can be authorized to go in the iTunes store. The one they'd like you to use, and Apple is trying to push, is the language Swift, which will be a new language for most of you, but actually it's quite a nice language. It's not too difficult to learn. So you could use Swift, and you could use the iOS things that are given to you by Apple. in the Apple Developer Kit. If you want to do that, you have to use Xcode, so you'll need to use a Mac. We do have some Macs available in the school, in particular the one in the user centre, so if you'd like to do that, I can make sure that you get the login to that and you can use that system. There's also Unity. Unity is a games engine that allows you to build things and deploy to various different places, including iPad and iPhone. You can also use a specialist system, especially for phones. The one that I've had the most success with is something called PhoneGap, which allows you to write in HTML5, so it's HTML, CSS and JavaScript, and then it allows you to convert it down to a phone. Moving on to look at Android devices. The main Android language is Java. Again, like iOS, there are conversion options, so you can use Unity, for example, to go down to Android. You can use PhoneGap to go down to Android. If you want to look at Xbox, 360 is really kind of deprecated now. It used to be a system called XNA, which is actually a really nice library to use. It was a really easy way to write a game. They've now got a similar framework, which is very similar. It uses C# called Monogame. So if C# is a language you would like coding in and one that you want to work in and you want to create something for either Xbox or for PC, you might want to look at Monogame as a library. If you want to develop for the Xbox One, then you'll have to use DirectX. That is not an option for light-hearted because it's not a very easy library to use. If you're doing PC, Mac or Linux, so mainstream software, this is incredibly open. Okay. It's worth really thinking about, do you need a games library or will a GUI library be enough? Do you need the high-powered stuff that games libraries do? Do you need a really good physics engine as part of your game? If not, then you can think about any of the graphics libraries. You can think about Allegro, DirectX, OpenGL, and how those would work. You can use any language you like, including C++, C# and Java. You can also, a few people said, can I use processing? You can use processing, and I know it's a visual language you've used in the past, so that might work well for you. I don't recommend it, because if you need anything like physics, you're going to have to do it from scratch in processing, and that is quite a lot of work. If you want to do it online, you can do HTML5 and JavaScript, probably PHP. You can still technically do Flash. Nobody has done a Flash game for a long time. Still technically exists. It is horrendous and not well commented, so I wouldn't recommend it. I would look at more the HTML5 JavaScript angle. You can also do Unity. Unity does compile down into HTML5 and JavaScript, so you can do web-based games in that way as well. There's also what I'm going to call develop once, deploy multiple platforms. So we talked about Unity a bit, we're talking about the phones, because it's the most common to use on phones. But the main powerful games engines these are that can be run in various different places. So you've got Unity, you've got Unreal Engine. Unreal Engine is very good if you want to do 3D things. Cocos 2D. I actually quite like Cocos 2D because there's lots of nice tutorials for it and it is open source. And it's C++, which is a language you guys know well, so that's quite nice. Unreal Engine, of course, now is also open source. There's Monogame, which I've already talked about. Monogame uses C# and is a bit like XNA used to be for the Xbox 360, so you can do some really quite powerful games in Monogame. And there's Amazon Lumberyard, which is quite interesting because it integrates with Amazon Web Services. So if you want to do something that's going to use a lot of web type interfaces, web services run on a web browser, maybe you need to have online storage, then Amazon Web Services could be a good way to go, and then you go with Amazon Lumberyard. Some other considerations you might want to think about. Is there a technology you want to learn? So many of you this summer are going work placements. Is there a technology you need to learn for your work placement? If so, maybe you can do it as part of this module. You also might want to think about the time. So you've got until May, which now we're in January, seems like a long time away, but it's not that long. So is it the case that some of these options are really exciting and you'd like to do them, but you think it's just too time consuming for this project? Also, it's time to really think about the game aspect that you want to do. Will you need really good collision detection and a physics engine? Will you need good non-player characters? Will you need good security and social media integration? Some of these libraries do that a lot better than others, so it's worth really thinking about what aspects you'll need and making sure you choose a library that helps you with them.